let's look at the unit circle. All right, degrees to radians. I'm just going to go every day. I'm just going to be going over this over and over again. All right, so these are 30-degree angles. These are our 30s. So this is my reference for all three. Sorry, there's 4 up here. For all 4 of those angles up there, they have a reference angle of 30 degrees or pi over 6. This is 1 pi over 6. This is, if this is pi, then that means it's 6/6. What? Yeah. Yeah. If I were to split this into 30s, Bryce, if I was going to, let's take a step back. Bryce, I want to know why you're not, if you're that lost, that's like 4 days ago. So why are you not coming to tutoring? Well, I don't have time to go back 4 days. I'm going to, for you, because I care, just for a second, we're going to, just in case there's somebody else that's as lost as you are. Okay. So we're not even looking at this. All right, I'm just looking at this. Does it make sense to you that from here, all the way over here, is pi? Remember how we found that? It was 3.14. It was 3 radians plus a little bit more. Remember that? So if this is pi, if I'm going to split and I want to talk about 30-degree angles, then this is 30 degrees. 30 more would be 60 degrees. 30 more would be 90 degrees. 30 more would be 120 degrees. 30 more would be 150. 30 more would be 180. Can you say that there are 6 pieces to that pi? That's why this is 1/6 of a pi. It's 1 out of 6 pieces. So this is 2/6. So I'm going to go back now. I'm going to erase all this. Better? Okay. So if this is 1/6, and I could go all the way around, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6. Does that make sense, Bryce, that this is 6/6? That's 7/6. That makes this one 5/6. Then all the way around, this would be 12/6, right? Because it's 2 pi. 12/6. So that makes this one 11/6 pi. So I was just doing in terms of 6s. Now I'm going to look at, what is this one? This isn't 6ths anymore. These are 3s. These are pi 3s. So my reference angle on this is pi over 3. So this is 1 pi over 3. This is 2 pi's over 3. This is 3 pi's over 3, right? Which is 1 pi. This is 4 pi's over 3. This is 5 pi's over 3. And 6 pi's over 3, which is 2 pi. You don't count the middle on these because they're big sections. That into a smaller, you want them to be the same size. See how that's the same size? This is the same size as this is the same size as this is the same size. Can you see it? All right, fantastic. It's almost like we kind of want to, I like Essence's idea. Oh, look it. It messed it up.
Wait, is the last way really the same size? You know, what was extra?
It is the same size. We're going to do this. You can make your own. That's what I would do if I were you. I'd make my own. I would make one that looked like this before I took the test, and then I would make one that looked like this before I took the test, and then finally I would make one that looks like this. As long as you create it for yourself, sure, yeah. It's not something that I want you doing beforehand, but if you want scratch paper and you want to give yourself like a little reference sheet, then you could totally do that. And you're going to have time to do it too because the test won't be that long. Yes, Kane?
So if you could divide the pie into 3 equal parts, why is the radian not divided?
Why is the radian not dividing in? Okay, so that's a parking lot question, right? You want me to write it down? Okay. Dividing into 3 equal parts. Because I like it. We'll come back to it. Okay, so these are in fourths now. My reference angle on these is in fourths. Pi over 4. So this is 1/4. This is 2/4, 3/4. This one's the easiest one, don't you think? 4/4, 5/4, 6/4, 7/4. Yes. Aaron.
Well, is it true that if I have roughly degrees, and if you
I already see what you're going to do, and I don't want to do that right now.
No?
Nope. It's just one more piece. I'd rather everybody see it conceptually. That's algebraically, and you're absolutely correct. Okay. So I'm not going to do the whole. I think it's more complicated when you do the whole thing together, right? I would just rather split it up into 3 different unit circles and work with it that way. But, okay, so this one's for you, Essence. We can compare our polar plane to a coordinate plane with a unit of 1. Remember I was talking about a unit circle? Well, here's a coordinate plane with a unit of 1. Isn't this helpful?
Yeah.
So this is, if this is 1 unit right here, right, going out here, then this point is on 1, 0. Is that a better visual? It's like I blew up a coordinate plane so that you could see it, and then slapped that polar plane on top of it. So this is 1 unit. It's also 1, I don't want to say it's 1 radian, because it's not 1 radian. Its radius of the circle is 1. Make sense? And the radius of the circle going up to here is also 1. But if I were to put that on the coordinate plane, if this is my origin, then this is 0, 1. And this is -1, 0. And this is 0, -1. Okay? Okay, Andrew, let's stop spinning. And Bryce, let's stop commenting on it. Alrighty. Are we ready to move on? Okay, so we're going to use our polar plane right now to fill in our coordinate plane. Sorry, to fill in our unit circle. Okay, ready for this? Okay. Catherine, whatever you're doing, I need you to stop. What? Okay, so I'm going to find the cosine of 45 and the sine of 45 degrees. I'm going to use my special triangle to do it. So here's my special triangle. On a 45, 45, 90-degree triangle, what are my reference numbers? 1, 1, root 2. So this coordinate right here, if I'm talking coordinates, I explained to you guys that x comma y is also cosine comma sine. Correct? Where cosine coincides with my x value and sine coincides with my y value. Right, Edward? Okay. So, if I'm talking about the cosine of 45 degrees, cosine is adjacent over hypotenuse, correct? Or I told you it was the x-axis. So, Adjacent is my x-axis, right? And hypotenuse is my root 2. So this is 1 over root 2. That is my x value. My y value, or sine, is opposite over hypotenuse, which I told you guys, sine stands for the y. Isn't this my vertical movement, or my y-axis? So it's 1 over root 2. Yes, always from the origin. Just like on a coordinate plane, it's always from the origin. Okay. How are we doing on this so far? So it's the same thing you did yesterday, only I want to know what my cosine is and my sine is with the same triangle. That's what you were finding already. You were just finding one piece of it. I'm finding, now you're going to find the other one as well. You see what I'm saying? So when you found cosine, this is what you were doing yesterday. I just asked you for this. Just one of them.
Yeah, and then we just wrote one of those two things.
Yeah, you wrote one of those two things. So now we're going to, what you were finding was coordinates. You were either finding the x coordinate or you were finding the y coordinate for me. We're going to look at that right now, okay? So yesterday we were only finding one coordinate. Today we're finding the whole coordinate. Sorry, we're not one coordinate, one part of the coordinate. Today we're finding the whole coordinate. Yes?
I think we had tangent yesterday. Do we have it on this one?
Nope.
No.
We're not even going to look at tangent anymore.
Is that even x or y?
It's y over x. So we're not even going to look at it anymore. Okay, I'm just going to concentrate on this. So check this out. So this coordinate, I have 1 over root 2, 1 over root 2. Check this out. This coordinate is going to be exactly the same thing. So the cosine of 135 degrees, or the cosine of 3 pi over 4, is also going to be 1 over root 2. And the sine is also going to be 1 over root 2. Because it's the exact same triangle, right? The exact same triangle with a 1 and a 1 and a root 2. Only the only difference with this triangle is this is negative 1. Because this goes in the positive direction and this is in the negative direction on the x-axis. Well, why is this one not negative? Because it's going up. So if this is my y value, it's still positive. My x value is negative. So I need a negative right there on the one that stands for x. Yes?
Will the y value always be positive?
No, the y value is not going to be positive down here.
Even if it's going up?
Check this out. So I'm going to do this one over here. This one is going to be, on the x-axis, I'm going negative 1 over root 2. And on the y-axis, it's also going to be negative. So just if you only know this one right here, you actually know all 4 coordinates. All 4 quadrants, right? You just have to apply positives and negatives to it. So what about this one? Is it positive or negative on the x? Positive and negative on the y. So you just have to think of it as a coordinate plane, essence. No. Okay. It's negative, negative, but if I had this one, 1, 2, 3, negative 3, negative 4, would you turn those positive because they're both negative? No. So back to this. No. So it's the same rule. We're talking about a coordinate plane here. We're talking about a polar plane on the other one. It has nothing. Only time you change a negative to 2 negatives to a positive is what? When you're multiplying. Are we multiplying? No. I'm just trying to give you structure. Okay? Yes.
So you can have radicals as denominators?
Yes. I don't know why they try and rationalize denominators, radicals and denominators.
Yeah.
You don't need to.
Okay, so
Essence. But we don't have a negative over a negative. We have a negative out front here and a negative out front here. So we'll parking lot that one as well. Okay, let's move on. So I actually, you guys see what this screen is showing you? Is that I actually know all 4 of these coordinates, right? They all have something to do with 1 over root 2 because they're 45 degrees, and 45-degree triangles are 1, 1, root 2. The only difference is this one's going to be positive, positive. This one's going to be negative, positive. This one's going to be negative, negative, and this one's going to be positive, negative. What? It's just the quadrants. Okay? They look like... Okay. I don't remember. All right, so now we're going to talk 30s and 60s. Right? And I'm doing them together because they're both related because they're the same triangles that we're using, right? The same special triangles?
Oh, yes,
They are the same triangle. They're exactly, 30, 60, 90 is the same as a 60, 30, 90.
Yeah.
Right?
Yeah.
They're the exact same triangles. So, let's talk about the 30 first.
So, for 60, we will always be a 90 degree angle. Oh, it always been my 90. Is that negative?
Okay, so let me. Okay, so I always ask myself, what's the smallest leg? Well, the smallest leg has to do with the smallest distance, right? So this is actually 1. Thank you. Hope is not here, and Valerie is. Thank you. Yeah. Okay, so this side is 1. I always know the hypotenuse of this triangle is twice as big, right? So this is 2, and this is root 3. So no matter what goes in the numerator, what's my denominator going to be no matter what? It's always going to be 2. Here it's going to be 2 as well, because we are talking about the hypotenuse, right? Every single one of these, is it my hypotenuse in my denominator?
Yeah. If we're only doing cosine and sine, yeah.
Because it's talking about the distance across that circle. Yeah, all of them were, over the hypotenuse, right? Using the special triangle. Okay, so they're all going to be over 2. So now I just have to find the other piece. Well, right here, if I'm talking about cosine, cosine is my x-axis. Cosine for this is going to be root 3. Sine is going to be my y-axis, which is my this side of the triangle, which is 1. Make sense? All right, I'm going to get rid of this. I'm going to put this back over here, and now I'm going to show you the 60 degree. Can you predict what it's going to be? It's going to be this switched, because the legs switched, right? Does that make sense? This, my x-axis, is now the shorter leg, right? X-axis is the shorter leg, and my y-axis is the longer leg. So it's all got structure. So you actually know now how many pieces of the circle, how many coordinates. If you know this one, you also know, if you know this, you know this one because the legs just switch. And if you know these two, you know 2 more over here, 2 more over here, and 2 more over here, because all that's going to change is what? The signs. Right? Yes. there's only two triangles you have to memorize, 45 and a 30, 60, 90, and that's it. No. This is a 60-degree angle. When we're here, this is a 60-degree angle, right? We learned that this is a 60-degree angle up here. 30, 60. So that's when you use the 60. If I was here, I was at 30, that's when I would use the 30-degree triangle. Okay. Awesome. All right, so we could fill this in completely, right? This one is going to be, this one is going to be the same as this one, only the x is going to be negative. Negative 1/2. Positive. Root 3 over 2. This is going to be switched because the shorter leg is going to switch. So this is going to be 1/2, and this is going to be root 3 over 2, and this one has to be negative because it's the x. You guys ready for your homework?
Yeah.
That's it. That's the rest of this lesson. I'm going to pause it. I'm going to go over your homework. I'm going to stamp, and then I'm going to get back to you, and you guys can ask questions on your homework from yesterday, okay? So, oh, I need to do this one as well. Sorry, guys. Back up here. Here's the easiest one. So right here at this point, what's my cosine? No. Here. At this point. 1, 0. Right? My cosine's 1. My sine is 0. Because it's just like a coordinate plane. And here? 0, 1. And here? Good. Right? 0 for my x-axis, negative 1 for my y-axis. All right.